Hey guys, in today's lesson we're going to talk about adding and subtracting rational expressions. This is found in section 8-5, part 1 of your book. Our objective is to add and subtract rational expressions. So, adding and subtracting rational expressions, to add or subtract them, we first need to find the least common multiple of the denominator. Okay, so let's do that. Alright, so to find the least common multiple of the expressions, we first need to factor everything down as far as it can go. So if I have 12, I should know based off of a factor tree, but I'm just going to show you just in case you've forgotten, that 12x squared y will give me 2 times 2 times 3 times y. Nope, sorry. Not y, but 2 x's, 1 y. And then x squared plus 2x plus 1, if I do AC, that would give me x plus 1 and another x plus 1. Alright, so then if we keep going, 18, I'll do the factor tree over here. 2, 9, 3, 3. That would give me 2 times 3 times 3, 1x, 3 y's. And x squared plus 5x plus 4 will be x plus 1 and x plus 4. Alright, so the least common multiple would be what they share in common. So I have 1, 2 in common, 1, 3, 1 x, 1 y, and another just x plus 1. So the least common multiple here would be 2 times 3, which is 6, x, y, times x plus 1. And we'd be done there. Alright, let's go ahead and try the next one. Okay, so again we want to break everything down to its least factors. Alright, so if I break the first one down, the first one has a greatest common factor of 2. So that's 2 and x plus 2. Okay, the next one, if I break that down, that's 1 and 6 or 2 and 3. And it's going to be negative 3 and positive 2 that work here. So that'd be x minus 3 and x plus 2. Their least common multiple is going to, oops, wrong way, sorry. It's going to be x plus 2, so the answer is x plus 2. Alright, let's keep going. So the least common denominator says the least common multiple of the denominators of two rational expressions is also called the least common denominator. So now we're going to start trying to find the least common multiple of the denominators so that we can simplify rational expressions. Specifically, add and subtract them. Because remember, if you're adding and subtracting any fraction, they need to have the same denominator in order to add or subtract them. Alright, so the very first thing we're going to do is we're going to take a look at their at the denominators. Alright, so the first thing we want to do is factor everything down. So the first fraction is factored as far as it will go. The second one, however, is still 2x minus 1 for the numerator, but the denominator, if we do AC, would be x minus 1 and x minus 2. So here's the deal. In order to add these rational expressions, and you know what? I think I may have written this problem down wrong. Let me go back. I'm sorry. The original of this problem should actually be x minus 1. I apologize. Alright, so here's the deal. In order to add or subtract any type of fraction, like I mentioned before, they have to have the same denominator. So the first fraction has x minus 1, and the second one has not only x minus 1, but it also has x minus 2. So in other words, the first fraction needs x minus 2. So the only way for the first fraction to get x minus 2 is to multiply by x minus 2 over x minus 2. Notice that's not changing the value, right, of the problem, because to change the value would actually be to multiply by a number, but in this case we're just really multiplying by 1. Okay, so if I take the new tops here and multiply, x times x is going to give me x squared, x times negative 2 will give me negative 2x, And the denominator, I'm going to go ahead and keep this all factored. It's still x minus 1 and x minus 2. Okay, and then we're just going to bring that original second fraction back. So 2x minus 1, and then x minus 1 and x minus 2. So at this point, everything has the same denominator, right? Let's go ahead and combine our fractions. So once we do that, we will have, and I'm going to put this numerator in standard form. I'm going to have x squared minus 2x plus 2x minus 1 over x minus 1 and x minus 2. Notice the 2x's are going to go away. So I'm left with x squared minus 1 over x minus 1 and x minus 2. Our numerator then becomes, because we should still go ahead and factor this out, our numerator is going to become x plus 1, right, because that's the difference of squares, and x minus 1. And what's so nice about this one is that x minus 1 is going to cancel. And so our final answer is going to be x plus 1 over x minus 2. And we are done. All right, guys, let's keep practicing. All right, so then it says, what is the sum of the rational expressions? So let's go ahead and do this again. So we first need to start by factoring. The first fraction is fine. The second one is not. It's really negative 2 over, I should be able to take out an x, and I'll have x minus 1 left over. So again, they both share an x minus 1, but x is different. So I need to multiply the first fraction by what it's missing. Okay, so if I rewrite that one's going to be x, sorry, let's go ahead and distribute that also. That's going to be x squared plus x over x times x minus 1. Let's go back to the original, plus negative 2 for the numerator, and then still x times x minus 1. If I combine the like terms for the numerator here, that's going to be x squared plus x minus 2 over still x and x minus 1. That numerator needs to be factored. The factors of negative 2 that give you 1 will only be positive 2 and negative 1. So there'll be x plus 2, x minus 1 over x times x minus 1. And lucky for us, or nice for us, x minus 1 still go away. So we are then left with, as a final answer, x plus 2 over x. And know the numerator and the denominator, their x's cannot be taken out because one is addition and the other one is just a single x. So we're done. Let's keep going. All right, so this last one is subtracting. We really follow the same rules. There's just a small difference when simplifying the numerators, but really it's not much of a difference. All right, so on the first one needs to be factored. So the numerator is just fine, but the denominator need to be able to take out an x, and I'm left with x minus 2. And then on the second one, once again, x plus 2 is fine for the numerator, but the denominator, I should be able to take out a 2, and I'll have x minus 2. So let's check to see what we need. Okay, we already have an x minus 2, right? But for one of them, for the second one, we're missing an x. So let me go ahead and multiply this by x over x. And on this second one, we have a 2, right? So that means the first one needs to be multiplied by 2 over 2. Now all the denominators are the same. So let's go ahead and distribute our numerators. And so this first one will have 2x plus 4 over 2 times x minus 2. All right. Now, don't forget, this second one is, we have subtraction in the middle, so this is minus. And then if I'm going to do that, I need to put the numerator in parentheses. So this becomes x squared plus 2x, because I distributed the x, and then still 2 times x minus 2. All right, so if I distribute that negative now, I will get as a numerator 2x plus 4 minus x squared minus 2x over 2 times x minus 2. Let's keep going with that. Let's put the numerator in in order. And let's go ahead and simplify too. That 2x and negative 2x are gone. So really we have negative x squared plus 4 over 2 times x minus 2. All right, the first one, the numerator, we should be able to take distribute out a negative. So if I take out a negative, I'm left with x squared minus 4, and that's perfect for us because then we should see that the numerator is a difference of squares. So if we do that, we'll have x plus 2, x minus 2 over 2 times x minus 2. Last step. What is so nice about this? The x minus 2's are gone. So our final answer is going to be negative parentheses x plus 2 over 2x. One more try to go. Here we go. All right, so once again, we start by trying to factor. The first fraction is fine. The second one, its denominator needs to be fixed. So this is still 6x minus 7 over, we'll have x minus 1 and x minus 2. All right, so here we go. So with that being said, we need to figure out what they're missing. So they already share an x minus 2 in common, but the second one also has an x minus 1, so we need to include x minus 1. All right, now with that being said, let's go ahead and multiply. Now this top one, how fun. This is, if you want to, you can create a box, right, for this information, a binomial times a binomial, or you can do FOIL. Some people like the box more for our classes, so I'll go ahead and do the box really quickly. That's x and negative 1, and then x and 3. So this would be x squared, negative x, 3x, and negative 3. So they give us x squared plus 2x minus 3 for the numerator. And that's going to be over x minus 1 and x minus 2. Okay, don't forget this is a subtraction problem, so we're going to put minus in the middle. And then the numerator is still 6x minus 7. However, I should put that in parentheses because we're distributing. And it's still x minus 1 and x minus 2. All right, so I need to still go ahead and distribute the negative. So our numerator is going to be x squared plus 2x minus 3 minus 6x plus 7. And then x minus 1 and x minus 2. All right, we got to keep going. Simplify the numerator. We still have x squared for our numerator. 2x and negative 6x will be negative 4x. And then negative 3 and positive 7 will be 4. All right, keep going. This numerator, AC, you'll either do 1 and 4 or 2 and 2. And in this case, 2 and 2 will work. So we're going to do x minus 2 over x minus 1, x minus 2. Nice for us. The x minus 2's are gone. And so we are left as a final answer with x minus 2 over x minus 1. Whoops, that's a 1. Okay. And we are done, guys. If you have any questions, please be sure to stop by for tutoring. All right.